I'd like to welcome everyone to the webinar series of the Cybersecurity and Information Systems Information Analysis Center, CSIAC. Today's presentation is entitled Leveraging Machine Learning, How to Achieve the Right Balance Between Humans and Automation to Optimize Outcomes. My name is Steve Warzala. I'm the CSIAC Outreach Manager. A couple of administrative notes before we begin. First, all phones have been muted except for the presenters. Second, questions may be asked at any time during the presentation by utilizing the chat function. Time permitting, your questions will be answered at the end of the presentation. I'd also like to take a moment to acknowledge and thank our sponsor, the Defense Technical Information Center, DTIC. The funding that DTIC provides enables CSIAC to conduct these webinars. It's my pleasure to introduce our presenter for today's webinar, Mr. Richard Boyd. He is currently the CEO of Tango. Prior to founding Tango, Richard spent about a half a dozen years developing novel technological capabilities with aerospace contractor Lockheed Martin. In this capacity at Lockheed, he founded an innovation group called Virtual Worlds Labs, which focused on the emerging fields of virtual reality, augmented reality, and AI. Previously, Richard worked for 25 years with Red Storm Entertainment and 3D Solve. These companies were acquired by Ubisoft and Lockheed. I will now turn the presentation over to Mr. Boyd. Good afternoon, Richard. The floor is now yours.
Thank you very much, Steve. I hope everyone can hear me.
Yep, sounds good.
Good. Thank you. Thanks, everybody, for making time today. I know this is a topic that is on the minds of a lot of you, and we've got a lot to talk about in a reasonably short amount of time, so I'll just go ahead and wade right in. But as Steve mentioned, in my background and my team's background, it really has been deeply immersed in computer gaming. But I hope that for those of you who have played games, it's a natural fit to see the AI connection, because whether we were making games with Tom Clancy or with Michael Crichton or Douglas Adams or even Ozzy Osbourne, by the way, only one of them is still alive, and you can draw your own conclusions from that. But AI has always been an important component of that. If you want to make convincing characters, convincing environments, you need a good grasp of that. But what we're going to talk about today is a bit of a different animal. Machine learning, although considered a subset of AI, really is a different toolkit. We even think of it sometimes as a new step in the scientific process. And we will get into, I promise you at the end of this, exactly how we're beginning to apply it to understand human behavior better and see patterns of activity that can also help us with cybersecurity, especially the human element of that. So I'll start with just sort of a thesis statement that we do believe in balance here, that I'm not talking about machines taking over, but about how we become, as Hans Moravec says, ourselves in more potent form. How do we augment our human capabilities with technologies like machine learning and AI to help us perform better? And one of the sub-ideas here is that we believe pretty soon, if you're not availing yourselves of these technologies, pretty soon you're going to be considered handicapped. And those who become fluent with these capabilities, whether you're an individual, an organization, or a country, will outperform those who do not grasp this pretty quickly. And we'll talk about some of these ideas. So again, I've written a number of articles on this subject in TechCrunch and elsewhere, and you see the thesis statement at the top there. That the real key of this century is trying to figure out how to achieve that balance. You know, what activities, look at everything that you're doing in your organization and try to figure out what should be done by humans and which activities should be done by machines, because machines are just better at it. And we'll talk about some of those capabilities here. And again, you can see how I write about, I'm going to be at South by Southwest in 2 weeks talking about superhuman education. I've keynoted conferences like HIMSS and others talking about superhuman healthcare, basically saying that it's better to take advantage of these technologies than just try to go it alone as an individual, especially in these complex environments. So here's where I first got religion, I would say, on machine learning. If any of you have a Microsoft Kinect in your home, this was about 2009. I was at Lockheed with my colleague David Smith, and we were called out there to help them with some of the sensors that they were looking at for the Microsoft Kinect. So standing there on either side of me is Alex Kipman, the guy who invented the Microsoft Kinect, and Jaron Lanier on my other side, who I've shared a couple of stages with, going all the way back to 1994 as we've been building virtual reality applications. He's the guy who came up with the term virtual reality and invented the first data glove. So this is at Microsoft Research in San Francisco. And again, we came out there to see, like, hey, what kinds of sensors can we help put into the Microsoft Kinect so people can have these good new gaming experiences on the Microsoft Xbox. But very quickly, what attracted our attention even more deeply was how they were trying to teach the system what a living room was. Now, that sounds pretty simple to us, but at that time, asking a computer to understand, the difference between a table and a chair and a plant and a cat and a dog and a person in different kinds of environments and different kinds of lighting was a very complex thing computationally. But the big breakthrough there is the same breakthrough that allowed us to have autonomous vehicles all of a sudden. Instead of trying to have a human being understand the problem and sit down and program the logic into a computer, instead what you do is you give it every possible example of things it might encounter and have it basically infer its own rule set. So the problem they had is they'd already shipped Microsoft Xboxes all over the world, and they only had about 100 megabytes of available space. So whatever they did in terms of the logic to drive that system had to fit within 100 megabytes of space. So they used machine learning. They had a supercomputer, and they were feeding it like all these visual examples of video and imagery of European living rooms, Japanese and Chinese living rooms, American living rooms, both rural and urban, and like I said, instead of programming those rules in, letting it infer its own rule set. That breakthrough really clung to our minds and caused us to reconsider a lot of the ways we were doing things at the time. So one of the first projects we worked on at Lockheed was something called the Learning Registry. So Jim Shelton, the Secretary of the Department of Education, came to Lockheed and said, hey, we in the government have a tremendous amount of available information, but it is undiscoverable by teachers. We'd like it to make it available to all the K through 12 teachers in the country and higher ed and everyone else. Think about like the Smithsonian. Down in the catacombs and archives of the Smithsonian is everything that's ever been collected. And I use this imagery to think about it or help people remember this idea of the last scene in the Raiders of the Lost Ark, where there's incredibly potent artifact that now a clerk has put a little tag on it that says, Ark thingy, and they're putting it into this massive warehouse. So this is a really valuable thing, but how can someone find it when they need it? So what they were doing at the time is having humans look through pictures of, ancient Grecian drinking vessels and documents and that sort of thing, and then tagging it as they understood what it was. And clearly that was going to take way too much time. So what we built is a machine learning system that can read, first of all, but also recognize images. And if it encountered something that was already in its database or was within its understanding, it could go ahead and auto tag that thing for later reference. If its confidence level was below a certain threshold, say 65%, then it would submit it to human beings who would then say, oh no, that's not a Grecian drinking vessel, that's a Roman vessel from 100 AD. And again, the great thing and the important idea behind machine learning is once it updates its database with some piece of expert information like that, it never forgets it. And that's really what machine learning is at its core, is a self-reinforcing, self-improving database. Right? So that's that project. And one of the things I like to tell people is everyone talks about big data, but there's a big leap from big data to information, something that you can use. And then the leap from information to intelligence is even greater. And that's information that's been computed in some way that can be presented to humans so they can act on it very quickly. So then around that time is when, and these are in my PowerPoint, these are all animated and a lot more fun, but we're in a PDF here just to reduce human error, I suppose. But what you see here is me with Nolan Bushnell. He's the founder of Atari. He also founded Chuck E. Cheese, by the way, because he needed a place to put his Pong games to get quarters out of teenagers like me. But this is when Google invested in DeepMind and brought that capability inside of Google. One of the first things they did is said, can we use this machine learning approach to actually have a system learn to play Atari games? And again, it would have been pretty easy just to program the logic in, but the test here was, can a machine learning system just watch humans play, infer its own rules, and master it really quickly? And of course, it passed that test pretty quickly. And then the big news, which is now almost 2 years old, and everyone I think probably heard about this, is, we all said it's one thing for a machine to beat humans at chess, even though chess is a fairly complex game. But having someone win at the game of Go, we were predicting that was going to be decades away. A lot of people were predicting it was going to be a long time because of the level of intuition and even deception that really good human players bring to bear. And of course, as you see here, it's estimated there are more possible positions, as many possible positions in Go as there are atoms in the universe. So very complex system. But of course, that fell about 2 years ago. And since Go beat the number one, AlphaGo beat the number one Go player in the world, they've since made it's made a better version of itself. And by playing itself in what's called a sort of an adversarial network, it's actually improved itself even further. Now it's getting really, really interesting. And I won't go too deep into that there, but this is a field that's moving really quickly. That's why I have my little exponential curve up there in the upper right to remind us how fast things are moving. And then, this is a slide I've used for a while as I do conferences, speak at conferences like Mod Sim World and others, saying, when are machines going to learn to deceive and lie the way we do when we play poker? And again, lots of people all the way up through 2017 were predicting that it was going to be a long time before machines were going to be good at that. Well, we know now that at the beginning of last year, a pretty basic set of machine learning libraries set up there at Carnegie Mellon defeated all of the top Texas Hold'em players in the world. So it's learned deception. It's learned how to read when a human being is lying just from some of their tells. So now it's getting really interesting. And I think even some of these games like StarCraft and others, those milestones are beginning to fall too. It's something, especially in this cyber environment, we really need to keep a close eye on. And we'll get into some of the reasons for that, I think, that are probably already apparent to many of you. So here's a question. And this, I added these slides right before I came on here today because of some of the more recent and continuing activity that's happening here. But here's a question I would normally ask, and since I can't see all of you directly and can't see hands, when I talked about this at ITSEC recently, I said, all right, there's this event that happened in 2014 where the president of the Ukraine was dismissed or moved out of power. And I asked everyone, what do you think? Was that a coup or was that a revolution? Now you can answer for yourself there, but I just did a tour of Italy. I spoke at 5 universities in October, all the way from Bari all the way up through Rome and Venice and Florence. And I asked the students that I encountered there, this question, and it was pretty amazing to me to hear how many of them thought it was a coup. And of course, these are 2 different narratives. The revolution narrative is the narrative of the West. Right? Whatever you think the truth is, That's our sort of take on things, is that the people of the Ukraine moved this president out of power because of his alliance with Russia. The Russian narrative is that this was a coup. And usually I would ask the people who thought it was a coup in Italy, I mean, they tended to side more with the Western point of view, but they all had Russian TV on their satellites at home. So that's the messaging that they've been getting. So the narrative, this narrative information war is sort of heating up, or is really well in play now. And just to keep score here, I think we're losing it. All right. Here's a more sort of pedantic example. Think about, and again, if you were live here, I would say, how many of you have eaten kale in the last year? And probably most of your hands would go up, whether it was of your own volition or was forced on you by a spouse or by social norms. Many of us have been eating kale lately, and usually it's in a restaurant, it's massaged, it's got a carbon footprint of 22 or whatever. But I find it really interesting that 5 years ago, 6 years ago, the number one buyer of kale in the United States was Pizza Hut. And it wasn't for eating. It was for lining the salad bar with some garnish that never, it didn't turn brown. So that's what they used it for. People weren't eating kale to the levels that they are today. So what happened is a firm, and you can see sort of the person who led that firm right there, was hired to go build a market for kale. And they used the fact that many of us now are concentrated in these little echo chamber fishing holes on Facebook or in other social media places. And she worked with some technologies like what we're going to talk about here today, about how I can model the people that I'm trying to move. So if I can create a model of someone with a particular viewpoint, someone who today is very happy eating, iceberg lettuce, as you see up here in the left-hand corner. And I want to move them to a point where they're demanding more expensive massage kale that doesn't taste very good with a carbon footprint of X, whatever it is. And if I start with that model of the person, which I can derive from their social media accounts and other data exhausts that we're all giving off now, whether it's from our location services on our phones or what we're typing on Twitter or on Facebook or LinkedIn or anywhere, or Instagram or anywhere else, I can model people down to the household level. And then I could say, for a given region, if you want to move this person from one position to another, here's how many messages it's going to take. Here's what you have to invest. And I can start moving you. And there are, again, some other tactics that they use there beyond just the modeling of the people and then simulation of the messaging using tools like machine learning. But the other tool is, and I'll just go back here for a second to show you, like this idea of finding out who are the influencers that most influences those target populations. Let me somehow buy them. And it's surprisingly easy, by the way, to get someone like Gwyneth Paltrow or Snoop Dogg or anybody to do a tweet on your behalf. It's usually around $5,000 to $6,000, and they'll do a tweet for you. So it's no surprise that the Russians, for example, clearly now, and I don't think this is speculative anymore, so the evidence is in that they understood this weakness of our open, social network concentrated society to identify these pools of people, micro-message them, and use influencers to move someone into a belief system away from where they were initially. These are the kinds of tools that are really powerful, and you can use them a variety of different ways. Whether it's like, hey, I just want to have deeper empathy for my customers so I can understand what they want, so I can make sure I build what they want. That's like sort of the benevolent version of it. Or, I want to convince somebody that I want them to move from a Republican to a Democrat or a Democrat to a Republican. Obviously, that takes a lot more money today to move these well entrenched positions, but it can be done and is being done. So let's talk about some other ideas here. So one core idea is modeling people and moving them, and I'll go into that more in a second. The other is this incredible ability in machine learning, which is far better than what we have with humans, to be able to read large sets of, especially text documents. So one of the things we did with our Tanjo system for lawyers is as an exercise, we said, hey, let's give our system, our Tanjo brain, every single legal opinion in United States history since 1797 across all 417 jurisdictions. Now, that's something that no student would do, or even teams of humans don't do or won't do. But it is well within the bounds of machine learning today because machines can read really fast. And now not only can they read, they can understand not just the bags of words in documents, but conceptually parse and understand deeply the sentiment and all the correlations within textual documents. So we ended up with this massive correlation. And by the way, this took a little over a week for the system to go through this terabytes of information and create a complete networked correlated case study of every single one of these legal opinions. We can talk later about what that means. But this, again, is this central idea that I've touched on a couple of times. The first is that in the old, and this is me arbitrarily saying there are three stages of AI. In the first phase, and I arbitrarily say it's 1958 until 2009 when I got religion on machine learning, when you wouldn't ask a computer to do anything unless a human understood it completely and sat down and programmed the brittle logic. And again, that's why the initial autonomous vehicles failed and why we failed in a bunch of other areas of AI, because in many cases, we don't understand how we can recognize immediately a loved one's face in different lighting conditions, or how do we actually drive? Driving involves ignoring most of the input around you. Otherwise, you'd be crashing all the time or slamming your brakes on every time somebody walked up to the curb or rode a bicycle near you. The big phase end, the big breakthrough, as I said, is machines being able to learn from large examples and improve their own judgment. So in this phase, from 2009 until, again, my own arbitrary date of this year, it's all about data scientists. We can't find enough data scientists to get the data from these bad flat files or strings of user behavior on websites or whatever it is into a form that I can give it to the machines so that they can make quick run at it, where it's at least a little bit structured. The new phase that we're going into now is more about what I just talked about, is understanding and predicting and even, of course, manipulating human behavior. And that's where we're starting to find, we need to find behavior scientists that help us understand the human element of this. So one of the recognizing that, and again, this is my own thesis, we reached out to some of the top human behavior folks on the planet. So we've given 2 Nobel Prizes in this field in the last 15 years, I believe, including this past year. But I didn't go to the Nobel Prize winners because they're too expensive and arrogant probably with their wins. So instead, we went one layer down to Dr. Jordan Louvier, probably one of the most cited academics in the field of what's called choice modeling and human behavior. And Dr. Richard Carson, who's the head of the economics department at UCal San Diego, a couple of other people like Tiago Ribeiro and others, and worked into taking some of their algorithms from their decades-long research in how do people make decisions, and put that on top of our sort of data-derived models of people. And that's what we call personas. Now, in terms of marketing, and you can think about how you can apply this, but again, we all need, no matter what our field, understanding human behavior, whether it's inside of government organizations or in politics or in commerce, is incredibly important. And of course, kind of the holy grail of everything. If you can understand and divine what somebody wants or needs, or how to move them from a position they hold to another, you can move all kinds of mountains and worlds and money, of course, and be able to do what you're trying to do. So this is how things are done today. In order to get intelligence about people, today over $3 billion is spent in the United States just on things like e-panels and focus groups and customer research, where they ask people survey questions. Now, obviously, this is well, I don't know how obvious it is, but this is somewhat flawed in that one of the things we've learned, think about what Netflix learned when they were studying this, when they had their grand challenge around machine learning and recommendation systems, is you can ask people a set of questions, but the difference between what someone says they're going to do and what they actually do tends to be a lot wider than most of us think. And Netflix learned this when they said, tonight, would you rather, if they asked me, they'd say, would you rather tonight watch Lawrence of Arabia or Hot Tub Time Machine? And of course, if I know I'm being asked the question, whether or not there are people sitting around me, I would say, well, Lawrence of Arabia, of course, fabulous cinematography, great acting, sweeping, views and whatever. It's a beautiful cinematic experience. But what do I actually do when I go home and I'm tired and I've popped open a beer? I put my feet up on the table and I watch Hot Tub Time Machine. That's a big issue there. And of course, today with so many people online and all the data exhaust that's coming from app usage and the human attention that's being monetized today by Facebook and Google and LinkedIn, and make no mistake about it, no matter what you think about these grand technologies we've built, we're not using them to populate Mars or cure cancer. We're just monetizing human attention the way NBC and CBS and everybody did just 20 years ago. So hopefully we'll change that a bit. But what Netflix learned is don't ask people what they want, just watch what they do with their human attention, where they spend it, and that's an indication of who they really are and what they really want. This is a new idea still from Forbes, this idea of getting beyond just these rough segmentation models and doing more in-depth personas that have more than just like socioeconomic and demographic census data, instead have psychographic information about sentiment and personality. And that's a fairly new thing, but still most of the reports that people are spending millions of dollars on are fairly static, right? So, and even when they're doing these studies, they'll spend, a typical consumer goods company might spend millions of dollars on customer segmentation models, as they call them, and they'll end up with, there's 10 customer types in the whole world. And they'll have pieces of paper, and those pieces of paper go into a file cabinet, or at best they go into a PowerPoint deck that is still static, and they do these periodically. Well, one of the things we learned at Lockheed Martin, running big programs like WarSim and JSIM and that sort of thing, is what you really want is real-time data as often as you can, where you're actually simulating these synthetic populations of people, and you're testing the dime and Pamisi effects of every action you might take. And I know I'm speaking to the choir here with this community, but it's amazing to me as I go out talking to the Procter and Gamble's and the consumer marketing folks, is that they don't get that at all. So that's one of the things that we're exploiting at Tanjo is that we feel this is one time when I feel the commercial world is probably a decade behind where we are in defense. So instead, one of the early things that we did is we started saying, well, with this ability for a machine to read what someone's written and read what's written about somebody, and be able to form these models, let's look at people we can create. So one of the first we did is, and he's almost a year now since we've resurrected Victor Hugo, we had our machine learning system build this model. And so the first day we just released Victor Hugo on the internet. And I don't know if you can see the screen here, but I can just see like what's attracting Victor's attention. What is he seeing? What is he reading? And then he actually scores everything he reads. And again, the score is based on topic interest graph, but also sort of sentiment and that sort of thing. Is it positive? Is it negative? That kind of thing. And we did a whole host of folks. I think we have there's a couple of hundred of these now that we've released on the web. We can watch and see what they're interested in every day. We're now talking to educators about using these to, again, have historical empathy for different points of view from these personas across history. and everybody from Leonardo da Vinci to Isaac Asimov to you name it. So, and I know I don't have the video here. Normally I have a video that shows this. But the next thing we got to is how about being able to actually write to them or submit something to them and actually have each one of these personas tell us what they think about what I've written. So this is very useful in marketing and messaging and political campaigns and all sorts of things where you want to test your messages with your audience in a safe simulated environment where, again, you're not just doing 1 or 2 experiments. You can do 10 to the 8th if you want to, and really see how you need to sort of wordsmith your offering to get the best reaction to move someone along a path to where you want them to be. So this is a tool that didn't exist in consumer marketing or in political campaigns or anywhere until now. That's just, again, one of the ways we're able to exploit machine learning to get, and again, like I said, the most benevolent version of this is just deeper empathy with people. But then the other end of the spectrum, like Russia's using stuff like this to see how I can manipulate people into holding or reinforcing a viewpoint that sows discord. So that's the other end of it. And here's just how we think about how we build these models. Now, I always hold that there's some portion of the human psyche or the human, brain, the unfathomable human mind that's unknown, that we'll never know. But you can get pretty good at your prediction if you, again, start with at the bottom here, census data that you can get from the government, purchase data. We even have some customers in the UK where we're able to get a lot of that data, even under the more strict EU rules about personally identifiable information. Above that, if I can match that to any kind of other behavior, whether it's purchase behavior from credit cards or from loyalty cards, or of course tying to social media graphs, I can get the interest graph. And then above that, if I can see anything that they write or respond to, like or don't like, especially on social media or social listening, I can build a pretty good model of personality and sentiment. We almost made it, when we started Tanjo 4 years ago, we almost made a dating product because we realized when we released our system onto, I won't say the name of it, but, on a major dating app, we were able to form pretty deep personality models or Myers-Briggs-like models of everybody millions of people. And then all you need to do is have an algorithm for what kinds of people with what physical characteristics match well in harmony with other kinds of people. We decided not to do that, but it's still useful for building teams of people inside of companies or inside of government organizations, that sort of thing. And then above that behavior choice model, if I know, for example, how people with all the characteristics below there tend to make choices about, how they buy chicken in a grocery store or buy wine or buy appliances or choose who to vote for, I can then, again, use that tool, all the tools I just talked about, to test how to message them or micro-message them to get them to the position where I want to move them, all right? So that's kind of the model. And then I typically add this, or have been recently. Almost a year ago now, my father passed away. He was 85. He was a decorated Air Force Lieutenant Colonel, served in Vietnam, received a commendation medal for helping save 8,000 Cambodians in an airlift operation. Really interesting guy, but he didn't have LinkedIn. He wasn't on Facebook. No Google footprint really to speak of. So I was able to use his military records that I got access to, as well as private letters, and of course what I knew about him, to resurrect him. Now I have this animated version of my dad, who I can visit every day. And I will say, regardless of what you're thinking about this, it is oddly comforting to go there and see, like, what does my dad think about today? Even though this is a shadow of him, and somewhere up there on the interwebs, I wrote a deeper long form article about this experience that you can go see. But this is really just kind of interesting. And I was sharing this with my friends over at TRADOC at a conference recently, and they said, hey, what if, could you do this for George Patton? Could you do this for other, military leaders across history? Could we use this in the defense university to teach people more empathy or understanding of how great commanders made decisions? And by the way, we're still exploring that, but it's an interesting idea. And then I just threw this in here recently, just to show you how long we've been admiring this problem of how do you model people, but also how do you actually talk to them. We did a game with author Douglas Adams, the guy who wrote Hitchhiker's Guide to the Galaxy. The game was called Starship Titanic. We did the first natural language processing system for that back in 1997. We called it Velocitext. Douglas ended up calling it Spooky Talk. And it had a total sort of glossary of maybe 500 words, and there were over 10,000 different phrases that these guys could speak to you. But this was one of the first games where you could actually chat with characters and get reasonably good responses. And like he said, sometimes they're really spooky. And I did note that if you saw the movie Passengers with Chris Pratt and Jennifer Lawrence, this one bartender character I had in there kind of looks a lot like the character in the movie. Right. But think about this idea again. If I could go and collect these famous people from history and how they, what was their sort of mood, sentiment, position on things. And I could then write in, my problem statement here, like, hey, I've got a company. I'm thinking about extending a line of credit to do a big marketing campaign to launch this product, or whatever the decision is I'm thinking about. And then I could have all of these. And it could be these 5 here, or it could be thousands of famous people, or it could be my dad and my grandfather and folks like that. And they could Likert scale respond to help me make the decision that I'm trying to make. And again, I'm just kind of spitballing ideas with you here, but this is something we're actively working on. So I find it really interesting. And I know there's already this Center for Cyber Influence organization that's been stood up to try to detect and using tools, I hope, like machine learning, like what we're using, but then also trying to figure out how to manipulate or how to neutralize false narrative and then create our own positive narrative. And we've got to get better at it, as I said. As I travel around the world, it's clear we're being outgunned in this field. So this information warfare is real. Hearts and minds are important. And they're having a big impact on the strength of our country. So it's important that we really come to grips with these tools, become fluent with them, and start wielding them. Hopefully, and I look forward to the questions you guys have, but hopefully you have thought through some of these ideas and have some low-hanging fruit in your organizations where you can begin to apply these technologies. Right, and I'll stop here and happy to take any questions. I see a lot of activity in the chat area, so I haven't been able to read it all, but I look forward to questions.
Yes, our attendees were. Oh, I'm getting some feedback here. Our attendees were actually kind of dialoguing amongst themselves. Questions were being asked, and the other attendees were providing information. So there was a lot of there was a lot of activity that did transpire during your presentation. So that's always a good sign. So that's always a good sign on the when a presenter has a lot of activity like that. So one of the questions there is about the AlphaGo 0, which kind of interested in your thoughts on using that reinforcement learning in that process. Do you have any thoughts on that?
Yeah, so I mentioned 2 sets of technologies there. I mean, there's again, having machine learning do its own thing with unstructured data and have it figure out every hypothesis that might be true. and do that without any human interference. Then there's the supervised learning part of it, where you're trying to guide and reinforce, what those hypotheses it's determining are important, and saying, well, giving it sort of feedback in terms of, like, some of these are not as relevant to, even though you think it's interesting with your strange machine intelligence, it's not really relevant to the problem I'm trying to solve. So go deeper on these other things. But the way, as I understand it, with AlphaGo Zero, the technology or the approach, the method applied there was this generative adversarial network. And that's the idea of these two systems actually fighting with each other for the best solutions to different kinds of problems, and letting them, of course, iterate at machine speeds. So I believe that's one of the technologies that we're looking at really deeply, because it does let this machine learning capability improve at a rate far faster than any of us can do with human interference that slows everything down. That adversarial network capability is what Google has used to improve their language translation capability, and I believe is what they used to create this higher sort of version of AlphaGo.
Okay, thanks. Thanks for clarifying that. So I'm curious, like on the reinforcement learning. So I just saw that Google came out with this an algorithm that can be used. They scanned an individual's retina, and based on the analysis of the blood vessels in the retina, it could begin to predict the cardiovascular risk for a particular individual, and it was very close to like the standard, using a blood test, just within a couple percentage points. And I know they had a large data set, that they that the algorithms were trained on. So is that kind of similar to what you were describing with the AlphaGo?
Yeah, I think so. And again, the new sort of guidance is what you want is the largest data sets possible. And that's the only thing that's kind of holding us back today is, and I'll give you an example. Recently, we were doing work for an accounting firm. And what's happened, and I don't know if you guys were paying attention to this, most of us weren't, but in December of 2017, FASB, which is the sort of organization of accountants that sort of manages all of their standards, came up with new rules for how to deal with revenue recognition. And accountants were running around the country having conferences, trying to figure out how to get their clients ready for it and themselves ready for these new rules. So there were new rules in revenue recognition for companies, also in lease recognition. How do you actually recognize leased equipment? But not to mention the fact that the tax rules changed. So all this change was really causing slow human organizations to panic a bit. We brought the machine learning system to bear on that problem. And we showed up and said, all right, first I need, it's pretty easy to put the rules in, even though there's some gray area in the rules. That's like old AI. I just program in that logic. But now in order for it to understand how to apply those rules to messy human created contracts, I need every possible contract I can find that is a sales contract between companies or people. And so they said, sure, let's give you a database of those. And they gave us like several hundred. And we just sat there staring at them and said, no, maybe we weren't clear. That's insufficient, right? I don't want 300 or 500. I want 50 million if you got them, right? And ultimately we ended up finding about 3.5 or 4 million of them, which is usually the sort of the threshold that we want to have of examples, everything from a sort of simple purchase order that somebody scribbled on to 50 and 100-page contracts with warranties and disclaimers and milestone payments and all kinds of things. And we had to train the system on everything it would encounter in all those examples. And that's the key today. quick. When I hear about a hospital who has a massive database of drug interaction data that they're hoarding, and they don't know what to do with, it bothers me because I know that in there's rich data that can save lives. That if we could just let the machine learning system loose on all of that. In fact, let's put every drug interaction database of all 6,000 hospitals in the US in one big pool and let the machine read through it and find all the interesting correlations on its own. We can very quickly recognize new situations and stop people from dying unnecessarily in our hospitals. But that's the new way of approaching everything.
Yeah, I think the data set that Google used for that, where they were scanning the retinas, I believe the set came from about I want to say about 300,000 patients, was kind of in the the ballpark range of the number of folks that they had information on. So it having a lot of data is seems to be a very critical factor in having the process be effective. So
exactly. So that's the key, is finding good data sets, and it's especially challenging in healthcare, of course. But what's interesting for us, and even when I was at Lockheed, we found that we could get data sets from other countries, because after all, in some instances, people are just people. We have some cultural differences here and there, but generally people are people. And so if you can take data sets that don't have the HIPAA and PII restrictions to run these sort of methods on, you can really discover a lot very quickly. And it bothers me that I think when I look across government, for example, think about compliance in government, all the different compliance rules that we have in different organizations. Is anytime you try to do an activity, think about having a machine learning system analyze all the different compliance rules, deconflict them because they do conflict. There are redundancies. There's guidance that actually was created that neutralizes each other. But then have it give you some guidance about the thing you're trying to do, instead of turning it over to thousands of hours or hundreds of hours of analysis by supposed human experts. You could get instant answers before you go do the thing you're trying to do.
Right. Yeah. So if there was, some way that the data could be anonymized and any of the PII type of information stripped out, that I think that would be very beneficial in kind of advancing the state of the art. So. Let's see. So we had one individual had a question. Wondered if you had any thoughts on the shift kind of from machine learning to unsupervised learning using neural evolution search instead of the backpropagation algorithm. Any thoughts on that?
Yeah, I was hoping you weren't going to ask that one, because that one I'd have to. So I should have said up front, so David Smith is my co-founder. He's not here right now. My CTO is Ken Lane. Ken was the technologist of the year at Lockheed the second year after we were acquired. My little company was acquired by Lockheed. And David was the fastest person to senior fellow in Lockheed's 100-year history. I'm neither of those things. But I understand the technology enough to apply it. I've done programming in the past, but I don't want to tackle that question.
That's fine.
Yeah, because it's, I know that they would immediately say, oh, here's exactly our position. I just don't have it, and I'm afraid I would stumble.
Sure, not a problem. I'll just mention too that on our
10 points.
I'll just mention that. So I'll mention that on our website we have some technology forums. So if if you were interested in having David or somebody provide some feedback at a later time on that, we could post that information into the tech forum for folks if that was of interest. Of course, not obligated, but just let you know that is a possibility.
Yeah, I'm hoping to have the entire transcript of all the messages I see in chat. I think there's a lot to be learned. I can learn from everything that's going on there. We have a lot of experts. So this is great. It's a great community here.
Okay, super. So I had a question during your presentation. You kind of mentioned in one of your parts you mentioned sentiment analysis, and so one of the things I'm kind of wondering is, like, could that technology, could it be used in kind of Homeland Defense kind of activities? So say, just trying to going through the airport, the TIA process, could it help with the screening? Could we better identify folks that might be an issue, or border crossing, helping to identify, folks that, might be trouble or something of that nature. Could that, do you think that could be, especially now where you're saying the machines, they've been playing poker, and they can start to identify the tells. I was wondering if it could be translated to like I said, like a Homeland Defense type of function.
Yeah, I'll answer that by saying it's my sincere hope that if it's not already deployed, that someone's about to deploy that already, because it is something that is so obvious that we should be doing. And again, we have to recognize we're all in as David Brin says, we're in a transparent society already. But if there was a way for us to be able to move through our lives, move through airports without being stopped and frisked and having to unload everything and have everything scanned, instead, these sort of more passive methods of, again, monitoring human activity and then sort of matching up to other things to if nothing else, hopefully not act like Minority Report's precog and go ahead and put someone in jail before they've committed a crime, but instead, at least sense and bin sort, to use an old, computer algorithm. Here's all the people that are fine. These are the folks that you don't need to worry about, and here's some folks that we really do need to take a closer look at, and not bother the rest of the group. And I know that might sound like profiling, but that's exactly what you just described, right? Which is a machine learning profiling system that, again, is taking in all the correlated data from the past, but then also monitoring things like facial giveaways, like facial tics or motion differences that indicate someone might be at a higher level of anxiety or stress or nervousness, that indicates that and a good policeman or a good security person probably already has those kinds of skills, but having them in a machine system, I think, would be interesting for certain security environments.
Yeah, like you said, I think some folks have that, have that from experience. They've been able to identify some of those clues, those giveaways that, with but then I think it's that's the trick of trying to, how do you capture that subject matter's expertise, that experience, and put that into an algorithm that can, then, with image sensors and, make those same kind of correlations on its own.
Well, I mean, it's clear that's one of the areas where machines will be better, and already are, I think, better than humans. And again, we should be looking at everything where that is true or becoming true. So take radiology. When I encounter a young person today who says, yeah, I'm going to go to medical school and I'm going to become a radiologist, I look at them and I go, you need to rethink that. Because already today, machines are, I don't know if it's an order of magnitude, but it's dramatically better than humans in terms of reading X-rays and identifying issues and anomalies and diagnosing things. So that we've already passed that milestone. So that's probably not a good field to go into, and it's something humans shouldn't be doing. Every time there's a healthcare intervention today and a doctor fills out a form It then goes through this process of, what are the reimbursement codes, whether you're Medicaid or Medicare, or you have some insurance policy with Blue Cross Blue Shield. Today, whatever's assigned goes into a room of people, and people sit there and look at every reimbursement code. And that slows down the process. And also it's error prone because humans are error prone. And they look at those reimbursement codes. Well, that should all be automated with machines. Machines are better at it already than humans. So why do we have a bunch of humans doing that? The other example is JP Morgan recently said, this is pretty dramatic. I mean, it's a pretty big firm. And similar to the example I gave earlier, last year, just 6 months ago, JP Morgan was spending 360,000 hours a year of New York lawyer time, whatever that costs, right? So let's say it's $1,000 an hour. I don't know. So that's $360 million a year just analyzing loan contracts. This year, now that they've implemented their own machine learning capability there, they'll probably spend 3,000 hours. They'll never have to spend that extra 300 million anymore. And that's, again, how fast these things are happening. And every organization needs to look around and go like, what should I have? It's almost like we need a new skill or a new person, like a human resource officer who looks at the activity that you're doing and says, all right, where, do I need to hire a person for this or a machine? How much of it needs to be done by humans and how much of it is machine effort? And getting that right is going to determine the winners and losers everywhere, including combat.
Yeah, so it seems almost seems where there's something of a repetitive nature or a repeatable activity, where you get patterns that develop. It almost seems that in any instance, in any case where that's happening, that's where the machine could jump in and help with augmenting folks, taking over that part, and then like you said, then it can provide them that that information, that actionable information that they can make decisions and go off and do things.
Mm-hmm. Yeah, I think I was on a panel recently for ethics in AI, and one of the big philosophical discussions there is, can we build machine learning systems that are provably aligned with human values? And that's, I see a couple of questions about that today, and that's one of the things I'd want to know is like, do you have a good bot or a bad bot? What is your, if you're going to deploy machine learning within your organization, how do you want it to interpret things that aren't completely clear? And when do you want it to call a human expert in to make that decision? Today we have, autonomous weapons type systems that are capable of making their own firing decisions, but by protocol and by doctrine, we don't allow that because we want humans to make those decisions. We're not comfortable yet turning that over to a machine completely. And I think there's a spectrum of sort of value calls that we're going to have to make every time you start applying machines to some of these issues, whether it's autonomous vehicles or applying reimbursement codes to health insurance reimbursement, or just about anything else.
So another topic you had brought up was the kind of the disinformation that is kind of can be put out there, and I've read that AI and machine learning tools have been used to create these fake stories, things of that nature. So can using it on the opposite end, can that help detect and determine what's true or not? It's kind of hard to figure out what's really true anymore now.
I think over the last year, I think there's been a lot of debate about that, and we've all talked about the truth triad algorithms, that hopefully that can detect when something is likely to be false. Google already knows about that. Facebook already knows about it. It would be great if they would go ahead and deploy that sort of thing. They're not perfect, but they can, again, bin sort to the things that we need to be paying attention to that are likely not to be true. And then, it'd be cool if on every post, especially if it's not from a direct friend of yours, it's in your feed somewhere, had a score of like, you might want to think a little bit more about this before passing it on, because it's likely to, it looks like either because of the source or because of the language used or whatever, that it's you might want to fact check it a little bit deeper. We already have the means to do that. I don't know what the computational overhead would be for Facebook or Google or someone like that too. But that's the problem, is there's also an incentive alignment problem, is that they're not interested in like, how do we make everything the most, true. Just like, your Google search algorithm isn't about surfacing the most valuable thing that you're trying to look for. It's first going to show you the things that are mediated by ad spend. That's what the algorithm does. And in Facebook, it's about what's going to make you more likely to stay on Facebook, not what's most true. So how do you, have people, pay for a filter layer on their own social media and online experience that does check for that, because it's not something that commerce is going to care necessarily about.
Right.
That's probably a whole hour discussion we could all have about how do you do that.
Right. Well, I see we're already past our regular scheduled time for completing, but I wanted to and like you said, we could go on, I think, with this conversation for quite a long time, but I do want to thank you for taking the time to share the information with us. I think this is a fascinating area. I think there's more to come. I think we're going to see a lot more changes driven by this AI and machine learning capability, and you've kind of been on the forefront of this area for a while. So like I said, want to thank you for taking the time to share your information, your experience and expertise with our audience.
All right, it's been a great pleasure, and as I'm posting in there now, if I can learn to spell. I know there are bots for spelling too, but I'd love to continue the conversation, and I will get some answers to some of these questions by connecting you guys. You can look up David Allen Smith on Wikipedia and see some of his bona fides, but those guys can answer your deepest questions, while I'll handle the lighter philosophical issues.
Okay, well, I'll hang with you on the philosophical ones too.
Well, thanks, guys. I really enjoyed it. And thanks for all that you guys are out there, what you're doing out there to keep us secure and safe.
Okay. Thank you, Richard, and thank you to all our attendees for participating today. I hope you all have a great day, and hopefully we'll see you at the webinar next month. Thank you. Bye-bye.
Cheers.